This conference will now be recorded.
Okay, so good morning all and welcome back to the session that is Big Data Masters program, and we guys are going through with distributed processing with PySpark. In the previous session, we have discussed about resource level optimization. We know uh, if we talk about Spark, then we are having multiple jobs and we need to do the optimization onto top of those particular jobs in order to minimize the latency. Our main job is to minimize the latency. Okay, so that we need to check the different ways how a particular job can be more performant, more performant, or that can be executed with least amount of time or with low latency. So that is our prime target with respect to PySpark job optimization. And what we have seen over there, like we are having two types of optimization. First one is application level optimization. And with respect to the application level optimization, we are thinking in order to change the code, in order to apply certain optimization technique inside the code only, so that we will be able to take the benefit. We will be able to minimize the latency. And what are those application level optimization techniques? So say partition by, bucket by, reduce by key instead of group by key, uh, join, cache, persist, avoiding collect. So these are nothing but application level optimization. We just used to put certain, you can say, a line of code, and then with the help of that we will be able to minimize the latency. Then this is fine. Say based upon the code we are able to do the optimization, but what about the resources? The resource which I have given for the execution of that particular job, is that particular resource enough for the execution? So that is nothing but resource level optimization. And over there, we have discussed about fat executor and thin executor, like all the resources which are given in a particular cluster. Those particular resources are divided in terms of executors. Executors are nothing but, you can say, containers, like combination of memory and core. So memory and cores are given to a particular job, or executors are given to a particular job, and based upon the resource which we, or based upon the size of container, we are going to say, mention, say this is the fat executor and thin executor. So with respect to thin executor, our main approach is to provide minimum resources. And what is the minimum? Like at least one core should be given to one executor. So one core plus memory, that is thin executor. Fat executor, maximum resources are given. We are trying to give maximum resources to a particular executor. But both of these two approaches are having certain drawbacks in terms of, like, once we were having thin executor, then broadcasting was a challenge. We will be having multiple copies of a particular file which is being broadcasted throughout the cluster among different executors. So this is a challenge in thin executor. Fat executor, once we are having fat executor, so in our research it has been identified that once we are providing more than 5 core to a particular executor, then performance is not as per the increment in the executor. Okay, like if we are going to increase, if we are going to double the resources, then we are expecting the performance must be doubled. But it is not like the case. So the throughput is, you can say, disturbed in that particular case once we are having more than 5 core in a particular executor. So we are not moving with fat or thin approach, we are moving with the customized approach. So customized approach, we are trying to have 5 or less than 5 core in an executor, and based upon that, like we are going to divide the resources, and we will be having some number of executor in the cluster, and those executors will be given for the execution of a particular job. So that is what we have discussed in our previous session. Like we have started a resource level optimization, and with respect to resource level optimization, we have discussed this particular stuff: fat executor and thin executor. But guys, once we are discussing about resources, okay, so memory and core, these are the two, you can say, main thing uh, from the resource perspective. So we have discussed with respect to executor, like say this much of core and this much of memory is given. But like inside, if we talk about memory, there are a lot of things inside the memory, and those particular things are, you can say, coming inside the memory management. So let me start a new topic, that is memory management. Memory management. So memory management. Now we know that, like Spark is in memory compute engine. Okay, so the execution inside the Spark is happening in memory. Okay, RAM is utilized in order to do the execution. But we have studied, we have gone through with certain aspects like caching and persisting, cache and persist. Like we are going to store the intermediate outcome inside the memory only, and as and when required, we are going to utilize that particular intermediate outcome in order to get the final outcome. Let me mention over here. So execution is done in memory, is done in memory, that is fine. Then cache and persist, like storing the intermediate result, intermediate result, that is also done in memory. Okay, so we can say storage memory. So if we talk about memory, execution memory, so there are two types of memory. One which is responsible for execution, because like execution is done inside the memory, and second which is responsible for storing the intermediate result, so that is storage memory. If we talk about Spark or PySpark, then like we are having two types of memory. At this point of time, what we can say, we are having two types of memory, like execution memory and storage memory, which is like utilized for execution and storage. But what is happening, these particular memories, execution memory and storage memory, these particular memories are going to share a unified location. Unified location, what is the meaning of that? It is not like, say, uh, we are having separate, you can say, allocation, or we are going to mention, say, this is for execution memory and this is for storage memory. Let me take an example. Say, if I'm saying, spark dot executor dot memory, okay, dot memory, and what I can say, this memory is, say, a 64 giga, 64 gigabyte, so say I have mentioned, say, executor memory is 64 g. So do I mention like this is for execution memory or this is for storage memory? No, I have not mentioned in this particular way. I have given the executor memory and that is of 64 GB. So these particular memories, okay, let me mention storage memory, storage and execution memory inside Spark are going to share the unified location. It means it means the memory which is given inside the executor, that will be shared among these two. Okay. So it is not like say this is for executor or this is for storage. But what will happen? This 64 GB will be shared for both of these two. We are having always like high priority for the execution memory. Execution memory is having high priority with respect to storage memory. Okay. So what is happening? Say if we are having this memory, say this is the complete memory what we are having. This is the complete memory. Now, say this particular memory is utilized by say storage. Say it is utilized by storage. Storage memory. Storage memory. So what is the meaning of this? Like execution memory is always having high priority. If we are having storage, if this particular memory which is the unified region and that unified region is shared among both of these two memory. So if this location is utilized by storage memory and there is something for execution, then this storage memory need to like evacuate all of the, you can say, uh, uses all of the data from the memory, and then the execution will happen over there. It is not like say like if something is occupied by storage memory and then like until unless it will not free, uh, the execution will go in, you can say, lazy state, or nothing will happen over there. The execution will not happen until unless the storage memory is not cleared. It is not like that. If something is there for execution, then storage memory need to be cleared, and then execution memory is going to occupy that particular space for the execution of those particular jobs. And uh, execution memory is always having high priority. Okay, so if execution memory is having high priority, then then what will happen? Uh, this we will not be able to, you can say, store data inside the memory. So we will not be able to store, but like caching is a phenomena. And what is saying, like if we are having something like intermediate result locally available inside the memory, that will boost the performance. So uh, like the entire memory is not freed, entire location is not cleared, we are going to reserve certain amount of, you can say, memory in over here for the storage perspective. Let me mention over here. Say, this is for storage. Now the modified approach, what we are having. So this is the initial way. Now what we are having certain, we have done certain modification. We have done certain modification, and with respect to that particular modification, say this is reserved for storage. Reserved for storage. So this particular portion, which is, let me mention in this RS video, reserved for storage. Okay, so this was the initial stuff. Once when like storage memory and execution memory, say storage, execution memory and storage memory, both of these two are going to share the unified location. Over here, like we are having the same stuff, but what we are doing, we are reserving certain portion for caching perspective. So now this particular, the remaining area will be shared by execution and storage. Over here, this particular portion is shared by execution and storage memory. If like there is nothing for execution, then entire memory is, you can say, can be utilized by storage memory. But if there is something for execution, then like execute, the storage memory need to evacuate this much of space only. Okay, this particular space which is like mentioned over here, it will be reserved. Or you can say this is the mixed approach, where we are having the flavor of storage memory plus execution memory. Over here as well, the execution memory can evacuate the storage memory, but for this much portion only. So this mixed approach is having certain benefits. Previously, like over here, we are having the benefit of caching and persisting. We will be able to cache the intermediate result over here, which is being utilized heavily, and that will, those particular results will be locally available in order to boost up the performance. So this is the mixed approach, and there are having certain benefits, and that's why like this particular mixed approach is being preferred. And over here, like nothing reserved for the storage, and the entire memory can be utilized for execution or can be utilized for storage. But once like the execution is come, the applications are coming, then storage memory need to evacuate the entire memory. So this is like this particular approach is having certain drawback, say approach 1 and the approach 2. Okay, now you need to tell me, say I'm going to cache, I'm going to utilize cache and persist. Now, now if like this particular portion is filled, this particular portion is full, and still I want to cache, still I want to, you can say, persist certain data, then where I'm going to persist that particular data or intermediate result, where I'm going to persist, where I'm going to persist the intermediate result if this particular portion is full.
Where
Persist
is
is
you
what?
where is mentioned the storage memory, there is like this portion, first portion.
So say this is 2 GB space, and it is full. Okay, we are having data in this particular location, but still I'm having certain data that I want to cache, where I'm going to cache at that moment. And you can think this particular portion is utilized by the execution memory. I'm not having memory in order to cache the data frame or already. Where I'm going to cache in that moment? Cache, not cache, but persist. Okay. So just pay attention over here. We are having disk as well. And this is nothing but disk. Disk is nothing but hard disk, you can say. Storage. Storage. Once I talk about once I used to mention say storage. Disk and storage both are the same thing. Storage memory, like this is memory basically, and memory is nothing but RAM. So say previously what was like, if we are going to discuss about first approach, like entire the memory can be shared by storage and execution. But over here, like if we are having for execution jobs for execution, then we will not be able to take the benefit of caching is, in this particular case, because nothing is reserved for caching perspective. Approach number two, what it is saying, like we can have certain amount of reserved memory, okay, that will be utilized for the caching perspective, and the remaining portion can be utilized for storage and execution perspective. And if like we are having nothing for execution, then this portion will be utilized for storage. But if we are having certain jobs and we need to do the execution, then the execution memory will have the high priority over here, and storage memory need to evacuate this much of portion. However, this will be reserved. Now, approach number three, what it is saying, say I'm having this particular portion for the reserved memory, which will be utilized for the storage memory in order to cache the intermediate result. But I'm having more data that I want to cache. So in this particular case, we have used the persist level, storage level, like memory and disk. These particular storage level, probably if you are able to recall memory and disk, okay, disk. So memory and disk. So over here, I'm going to utilize the mixed approach. Say certain portion of the data intermediate result, basically it will be cached inside the memory, and the remaining portion it will be cached onto the, not cached, basically caching is done inside the memory but persist, and the remaining portion will be persisted onto the disk. Okay, say some portion is there, some portion is there inside the memory and some portion is there onto the disk. Okay, so approach number three is saying, say if we are having more data to cache or to persist, if we are having more data to persist, then we can persist that particular intermediate result on disk as well. Okay, but over here certain algorithms are working. Try to focus over here. Over here certain algorithms are working. So the data which is being utilized heavily, if we are having certain data frames, say I have like 40 data frames and I have persisted all 40 data frames, so all 40 data frames in an application, and some data frames are being utilized heavily and some data frames are not utilized, and those probably will be utilized after some time and whatever. Okay, so the portion or the data frames which are being utilized heavily, those particular data frames are cached inside the memory. Okay, and the remaining portion which is having least uses, okay, that is stored onto the disk. And over here one algorithm is working. Algorithm name is LRU algo, LRU, list recently used, huh? So the this particular algorithm, list recently used algorithm, is keep on monitoring onto this particular data, and it is going to say monitor this particular data, and the data or data frame which is list recently used, which is uh, not frequently utilized or used, then it is going to check that particular data frame, and it is going to move that particular data frame from memory to disk. And that particular you can say that particular phenomena is known as block evacuation. Okay, block evacuation, like evacuating the blocks of storage memory which is least recently used. And uh, from here it is going to, you can say, check the LRU is also working over here. Okay, and the portion which is heavily utilized, like which is called inside the execution memory from disk, like say this particular portion is utilized heavily, so this particular portion is moved from disk to memory, because like the portion which is being utilized heavily, that must be available locally inside the memory. Okay, and if that is available, then the application will be boosted, that particular application will be having low latency, and we will be able to do the execution in least amount of time. So certain stuffs are there. Let me repeat it once again. Once we are having too much data in order to persist, then mixed approach like memory and disk is being utilized. The portion which is utilized heavily, that is kept inside the memory, and the portion which is least utilized, that is kept onto the disk. And still the LRU is working in order to move the data from disk to memory and memory to disk. Okay, so recently used algorithm is working, and it is keep on monitoring onto the data frames which is not utilized heavily, or which are having least usage. So those particular data frames or portion will be moved onto the disk, and that particular process is known as block evacuation, evacuating the blocks of memory, storage memory, and moving those particular blocks or data frame from memory to disk. Okay, so this is about, say, execution memory and storage memory. Just have a look and ask if you are having any doubt, huh? Just have a look and ask if you are having any doubt. Rohit, Shivam, Naresh, Swati, Rahul, Vandana, any confusion? Any confusion? Okay, so
One
what
thing
I
I
can
just want to
assume,
ask,
there's no confusion, huh? Yes, yes.
like, is there any
Come
way to
again.
check that also? Like, I just want to ask one thing. Is there any way to check that also? Like how many uh,
Storage
data we
memory
have?
and
Uh,
execution memory, huh?
yes, yes.
Okay, we are going to discuss that particular stuff, huh? Good question, huh? So if you are going to say mention what I have mentioned over here, like say Spark dot executor memory 64 GB G. So it is not like that. Say this is complete for storage and execution memory. Okay, this is not the case. What is the internal distribution over here? If we are mentioning say 64G, so it means like it is the combination of heap memory of and heap memory, heap memory. Okay, so this 64G is the combination of heap memory and off heap memory. Heap memory or off heap memory basically the memory outside the JVM, outside JVM, outside JVM or inside JVM. Java Virtual Machine. You know, like all the Spark programs are executed inside the JVM only. So heap memory inside the JVM, and this is a storage level as well. Okay, in order to persist a particular data frame or RDD, we have gone through with certain storage levels. Storage level like say memory and disk 2, disk only 2, disk only 3. Okay, uh, guys, just give me a minute. Give me a minute. Huh. Okay. So, huh. So we were discussing about storage memory and execution memory. Once we are going to mention say 64G, it is not like say this is utilized for storage memory or executor memory. Like there is certain other calculation. So once we are going to mention 64G, it is like the combination of heap memory and heap memory. Heap memory inside JVM, of heap memory outside JVM. And this is the same thing of heap memory, like the storage level inside the persisting. We have seen like this persist level of heap, and once we are going to utilize of heap persist level, then on side the onto the off if memory or outside the JVM, the data frames will be persisted. So off if is the that particular memory. Now, once like we are having, say, let me take an example. Say, say 4 GB, or let me take say 8 GB. Say Spark dot executed dot memory 8G. So 8GB basically. Now Spark dot executor dot memory 8G, and the percentage for off if memory, there is a calculation like it will be 10% of heap memory, 10% of heap memory, or or 384 384 megabytes. Okay, so let me mention what we are having. We are having heap of heap memory and heap memory. Heap memory and of heap memory. This is complete say 8 GB. This is what we have mentioned. Like for the executor, if I have mentioned 8 GB, so this is the combination of this particular memory. Okay. So if I'm going to take say 10% or 7 to 10%, 7% to 10%. 10%. So heap of heap memory, it will be by default 384 MB or 7% to 10% of heap memory. So this is the calculation which is there. This is default, and even like we can decide if we want our of heap memory 10% or 7% or 5%. That will be decided by us. By default, it will be 384 megabyte. Now, say if we are having 8 GB and 384 MB is given for off if memory, then what will be remaining over here? It will be say, let me take say 400. Say 400 for the calculation, 400 MB is given to off if memory. So around 7.6 GB, 7.6 GB, that will be there for heap memory. Try to focus over here. This will be for heap memory. Heap memory. And this is a 400 MB that is given to of heap memory. Now GB 7.6 GB is there for heap memory. So do we need to understand like 7.6 GB is for storage memory and execution memory? No, it is not like the case. Now this particular portion, what we are having for heap memory, that is further divided. Let me take the heap memory. So what we are having 7.6 GB, 7.6 GB heap memory. This is the heap memory what we are having. The heap memory. Of heap memory is this much, like say around 400 MB or 7 to 10% or 384 MB by default. Now from this particular portion, what we are having, 60% of this is given, around 60%, say this much. This portion is given to storage and execution memory. Let me mention 60% of this, 60% of heap is storage plus execution memory. Then 40% of this, that is user memory. 40% is user memory. And over here, 300 MB, 300 MB, that is reserved. MB. So this is what we are having heap memory in total. This is heap memory. Okay. So what I have explained so far, like if we are going to mention say 8 GB, 8 GB is not the complete memory which is given to say storage and execution. There is certain calculation which is happening inside the that is coming inside the memory management, like how this particular memory is managed. So if you are going to mention say 8G, so this is the combination of heap memory and off heap memory. So off heap memory is given to 7 to 10% of heap memory or 384 megabyte. Okay. Or let me take, we have taken say default, we have taken 400 MB for our calculation. So remaining 7.6 GB is for heap memory. Now this 7.6 GB heap memory is further divided into storage plus execution, user memory, and 300 MB, that is for like reserved for the R&D perspective. User memory, this is utilized for say data structure related stuff and out of memory error related things. Okay, so for those particular stuff like user memory is there. Now this particular portion, 60% of heap memory. Okay, if we are going to calculate say 60% of heap, that is around 7.6 and 60%, it will be 4.56, 4.56 GB, that is given to storage plus execution. And 40% of this, that is around 3 GB, that is given to say user memory, and 300 MB for, that is reserved. Let me mention RSVD reserved. So this is the way like how the storage memory and execution memory is given inside the PySpark. Now there are certain parameters as well which are you can say going to uh, give us the information like how much memory we can have. So over here certain parameters, and let me try to mention those particular parameters. So we are having certain configuration config, and what I can mention is spark dot memory dot offheap dot enabled, and it is true and false. I can mention it true. Okay, so this is one configuration. Now threshold. So spark dot storage spark dot config spark dot storage dot memory fraction, memory fraction, and over here say what we can have, say 5%, or 50%, or 60%, we can decide over here 0.5%. Okay, so now I think Rahul has asked, so this particular parameter is going to decide. So we are having 60% of heap memory which is utilized for storage and execution, say 4.56 GB that is utilized for storage and execution. Now we are having this particular parameter which is driving this particular storage and execution memory. Yeah. Now if we are going to mentions is spark dot storage dot memory fraction. So say 50%, if like we are going to mention zero point 0.5, so 50% of this will be fixed for storage and remaining 50% will be utilized for execution. We can fix it to 20, 30, or 60. That is decided by us. By default is 50%, that is zero point 0.5, and if you want to have more or less storage memory, then you can tune this particular parameter, and you can have that much, you can say, storage memory or execution memory. Like if we are going to mention say 0.5 or 50% for storage, then remaining will be for execution memory. Okay, so that is the stuff. These are the controlling parameters which are providing the information, say this much memory will be used for storage, this much memory will be used for execution. Okay, just have a look and ask if you are having any doubt. Just have a look.
What is this user memory? What, what
Hmm.
does it do? This user memory, 40%.
Your voice is not clear. I'm not able to hear properly.
What is this user memory? 40%. What does it do?
Yeah, I mentioned user memory. Yeah. So user memory is used, say, if we are having OM error, we will be facing this particular issue. Like once we will deal with heavy data set, so out of memory, out of memory related errors, data structure related stuff. So for these particular things, data structure, like say we guys are going to utilize different type of data type in order to store those particular things, and if like certain errors are there, in order to tackle those particular errors, in order to maintain the logs for those particular error, this particular user memory will be utilized. And this is, you can say, fixed like 40% of the heap memory. Okay.
Okay. And then this in 60% of heap is storage plus execution. So is there any
Uh-huh.
way to like divide the data like memory part, like if we are giving 50%, so how much it is used for storage and how much it is used for execution
No, no,
in
that
this?
these are the controlling parameters at that moment. Like,
Hmm.
say, if you are going to have 50% of this for storage, then you need to tune this particular parameter to point 0.5, 2.5. Spark dot storage dot memory. This is storage memory fraction. Okay.
So
So
it is
based upon
it is
this, we will be able to get the information like out of this much, which will be utilized for storage, and uh,
okay. In 60%, we can say
mhm.
that in 60% we have divided it to like 50-50% storage and 50%
Hmm.
for
So
execution.
this is the controlling parameter which is going to decide, say,
Hmm.
we need to have 50% of this, 40% of
Okay.
this, 10% of this.
Okay. There this 60% is fixed. So in this
Yeah,
configuration
60%
we.
of heap memory. This is heap memory. In total, heap
Hmm.
memory.
Okay. 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 Clear.
Okay. So there are certain other parameters as well. There are other parameters as well. Uh, Let me mention. Okay, so heap memory, off heap memory, for off heap memory, we need to, over here the garbage collection is done. So garbage collection is done all for the off heap memory. So for off heap memory related things, what we are having garbage collection interval. So spark dot cleaner dot uh, dot periodic DC garbage collection dot interval. Interval. So these there are certain other properties as well. I'm just sharing the main properties only. Interval. So it is 60 60 minutes. So you can change it to 30. Okay, by default is 30. So after like each 30, every 30 minutes, the garbage collection is done. Garbage collection is like once we are going to utilize certain objects, once we are going to create data frames and all, so certain objects are created, and if those particular objects are not in use, those will be treated as a garbage. And if like we are having too much stuff inside the memory, or too much garbage inside the memory, that is, you can say, off if memory. Okay, and that will lead to, you can say, slow down the processes. So we just need to clear that particular garbage in order to boost the performance. We will be facing certain out of memory related issues due to garbage collection, like out of memory due to garbage collection error, off if memory is less, and we just need to tune the memory properties. How it will be less? Because like the things are being occupied by the garbage. So those particular things are there. In order to clear that particular stuff, we need to have we need to set these particular garbage collection related stuff. We need to clear the objects which are being available inside the memory. And once the garbage collection is done, once the you can say objects which are being which are not in use are cleared, then we will be able to boost the performance. So with respect to this cleaning, there are certain other parameters as well, like tracking and blocking shuffle and all. So I will share once we will be having you can say detailed discussion with respect to the garbage collection. But uh, from the memory perspective, the things like we are having two types of memory: executor memory and storage memory. And if like we are going to mention certain amount of memory, it is not like say that particular memory will be utilized for storage or executor memory. So that is further divided into two things: heap memory and off heap memory. And heap memory is off heap memory is always 7 to 10% of uh, 7 to 10% of heap. And just give me a minute. Okay, so heap memory and off heap memory. And heap memory further divided into three types of memory: storage, execution, user memory, and 300 MB reserved. So 60% of heap, that is storage and execution. 40% of heap, that is user memory, that is utilized for data structure and out of memory related challenges, rectification. And 300 MB, that is reserved for the further analysis. Certain properties are there which are driving these particular configurations, like of if enable true, we can set the you can say percentage for off if as well. Okay, we can increase the size for off if memory as well, like spark dot say if we just want to increase the, if like we are getting the off related errors, we will, once we will be facing these particular challenges, we will be trying to rectify those particular uh, issues by changing these particular properties. Spark.memory dot off dot size, of if dot size. So over here we will be able to change the size, say let me mention 2 GB. Yeah, so if we are facing this much like memory related challenges, then we can increase the OFIF memory size as well. Now OFIF dot size, we are having this particular parameter. So these particular things will be you can say coming what you will be able to digest these particular things. We will be, once we will be getting these particular error at this point of time, just try to like keep the this particular property in your mind. And I will recall I will remind you that this was the property which we have discussed. And now in order to remove this particular error, say of if um, like out of memory due to garbage collection related stuff, then by tuning these properties we will be able to remove those particular error, and we will proceed for the execution of the jobs. So that is the stuff with respect to memory management. Execution memory and storage memory. So it is not like, say, if we are going to mention 64G, so entire 64 GB will be utilized for execution and storage. It is not like, certain calculation is there, and based upon that particular calculation, like, we will be getting user memory, storage memory and execution memory, which will be responsible for the execution of our jobs. So that is memory management inside the PySpark. Just have a look and ask if you are having any doubt. Just have a look. All of you, Shivam, Naresh, Swati, Rahul, Vandana, Rohit. Any doubts so far? Anything that you are
And,
not able to digest?
um,
So can we just have
Clear?
one review, like where off heap comes into picture and where heap comes into picture?
Heap. So heap is inside JVM. All the execution is done inside the JVM in PySpark. Entire execution is done inside JVM. Off heap is just utilized in order to maintain the the objects which are being created, and those are not in use. Okay, so that is utilized in order to have that particular stuff. And once, like, we are having too much, you can say, objects inside the memory, like, which is being not in use, that will be, you can say, there, that is going to occupy some space onto the off heap memory, that is outside JVM. Okay, so once we are having too much objects onto the off heap memory, from the PySpark perspective, like, the JVM is there, and that is, you can say, that is preferred one. But off heap is utilized in order to maintain the created objects, and we need to clear that particular memory in order to boost the performance. For the execution, heap memory, off heap, just to maintain the dummy objects, or the objects which are not in use. Right? Swati, is it fine? Is it fine? Naresh, Swati, Rahul, Vandana, Rohit.
Yes.
Okay, so the next topic that we are going to discuss, that will be AQE, adaptive query execution. Okay, AQE, yeah. Adaptive query execution. Okay, so this particular property came inside the Spark 3.0. This particular property introduced in Spark 3.0. Now, AQE. So, what is happening inside this PySpark or Spark? Like, Spark is lazy in nature, and it is going to prepare a DAG, and based upon the DAG, the execution will happen. Okay, so AQE is an optimization technique, like what uh, we have gone through with certain optimization technique, and AQE is like another, you can say, set of optimization technique, or like the combination of multiple optimization techniques. We are having multiple things together which are provided by AQE. So like over here, inside the PySpark, what is happening? Say we are having a particular like DAG, that is directed a cyclic graph without AQE. What was happening? Like based upon the DAG, a plan is prepared. Okay, and that will be a static plan, basically static plan. So a static plan is there, and based upon the static plan, the execution will happen, and we will be able to get the outcome. Okay, so what was observed, like once we are performing the execution of a particular job, then there might be certain change inside the cluster configurations, like the resource availability, or we need to increase the partitions or decrease the partitions. Okay, and we need to prune certain partitions, we need to prune certain columns, so those particular things we need to do in order to like have the better performance, so these particular that particular stuff was not available, like entire thing was based upon the static plan, like whatever we need to perform, a plan is prepared, and based upon the dynamic stats, like the actual configuration of the cluster, or actually what is being happening inside the cluster, and in order to tune the things, so that particular stuff was not available before AQE. Okay, now once the AQE is introduced, and what I have mentioned, it was introduced in Spark 3.0, so it like what this AQ is doing, it is going to have the dynamic stats, so it will, like we will be having dynamic stats during the job execution, like available resources, data size, optimized plan. So previously, like each and everything was based upon the static plan. Okay, now it is going to monitor the dynamic stats, and like what are the available resources, what is the data size, and based upon those particular things, optimized plan is prepared, and that particular plan will be executed. That is possible based upon the AQ only, that is adaptive query execution, like dynamic the execution is done based upon the dynamic stats, and dynamic optimization basically like real time optimization, what we can say na, dynamic plan based real time optimization. So what I can say, AQ is an you can say optimization technique which was introduced in Spark 3.0, which is like providing the optimization based upon the dynamic stats, based upon say available resources, data size, and like optimized plan, and then we will be able to get the better performance, which was not possible with static plan. A static plan was like before the execution a plan is prepared, then uh, there is no any stuff in order to mold that plan based upon the available resources, data size. Uh, what we have seen, say the repartitioning concept. So repartitioning concept is there, so we are going to say increase the number of partitions in the starting, so that like we will be able to take the benefit of parallel computing, parallel processing, and once the data size is reduced, then we are going to decrease the number of partitions, so that like uh, so that it is not like say the application master need to monitor too much uh, partitions, uh, and there will be say there is where like the data is very less, so so that particular stuff was done manually, like we are going to increase the number of partition, then we are going to decrease the number of partition. It was the manual task, we are not having we are having the information, say we guys are going to uh, work based upon the data, like this is the data, and based upon this, like this much of partitions will be good uh, for our uh, for the distributed computing. And now, like the data size is this much, and I can reduce the partition to this much. So those particular things are, you can say, static stats, and based upon those particular stats we are going to take the decision. But over here the system is, the Spark is going to decide each and everything. And Spark is dynamically increasing or decreasing the number of partition that is happening over here. So what is there? There are certain things which are provided by AQE. First one is adaptive skewness handling. Adaptive skewness handling. Adaptive skewness handling. Now, adaptive skewness handling, we can take an example. Say we are having 10 executor, and 90, you can say, percent load is flowing towards one executor, and remaining 10% load is given to rest of the executor. Okay, so this is nothing but data skewness. You can think in this particular way, like 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, and 10. We are having 10 executor, and say this first executor is having this much load. This much load is there to this particular executor, and rest, we can say, executors are having, say, less usage. Okay, that is like these particular dots are denoting, say, load. So we are having 10 executors, and this particular first executor is having 90% of the load, and rest 10% of the load is given to remaining 9 executor. So once, like, we are having imbalance distribution, that is known as skewness. This is famous interview questions as well. Like how you are going to handle skewness inside the PySpark. So AQE is the technique which is utilized in order to handle the skewness. We are having, say, bucketing, partitioning. Those particular concepts are also, or properties are also utilized in order to handle the skewness. So skewness is nothing but imbalanced distribution of the record, or imbalanced distribution of the data. That is what we are able to see over here. One executor is having this much of load, and remaining executors are having less, you can say, the 10% of load only. Now, because of these particular things, what we can have, we will be having, say, OOM error, out of memory error. Okay, so what can be the solution? We can have, say, coalesce and repartition. So this is the solution in order to, you can say, handle this particular issue. Skewness is there, and we are having coalesce and repartition. These are the two techniques. So uh, this is dynamically working inside the AQE. If you are going to enable this particular property AQE, so coalesce and repartition dynamically working based upon the data size, and we will be able to tackle this particular situation. So what I can say, repartition is nothing but like with the help of repartition and coalesce, we are going to increase or decrease the number of partition. And we know like df dot repartition, and we just mentioned say 10 now. So that particular data frame will be distributed, will be, you can say, converted into this much of partitions. And so this is the syntax basically. So over here, since skewness is there, if the data is skewed, one executor is having too much data and remaining executors are having very less load, then we can have this particular AQE. AQE is working and dynamically it is going to apply coalesce or repartition itself onto the data, and it is able to tackle this particular situation. Okay, that is nothing but data skewness. So we will be able to minimize data skewness, or we will be able to handle data skewness with the help of AQE. Once we are going to enable this particular property, we will be having dynamic partitions, like it is going to increase or decrease the partitions inside the job execution. So over here, like from the developer's perspective, we just need to set this particular property, and like repartition and coalesce related stuff, this will be managed by PySpark only. Okay, previously like what we have, you can say we have gone through with repartition and coalesce, and we have seen the manual approach in order to increase or decrease the number of partitions. But over here, based upon the dynamic stats, Spark is going to increase or decrease the number of partition by itself, and we will be able to handle the data skewness. Just have a look and ask if you are having any doubt with respect to skewness by leveraging AQE. Just have a look and ask. Rahul, Rohit, Swati, Vandana, Naresh, Shivam, any confusion? AQE.
Any configuration changes need to be done for this adaptive display, for this
I'm not able to
adaptive
hear
screen.
properly.
What is the configuration? Any configuration for this
What is the
adaptive configuration we need to change in for
that
this
I will
adaptive
tell
screen?
you. First, like we are going through with the betterment that is given by AQE. So this is the first stuff that is given by AQE. We are having certain other things as well. Second one is predicate push down. Push down. So predicate push down. That is a very famous term which is being utilized, which is being asked during the interviews. What is predicate push down? So basically, what is happening? Say, predicate push down, basically removing the unwanted data. Okay, removing the unwanted data. Predicate push down. Okay, say you can think in this particular way, like I was having a CSV file, and CSV file was having say 1000 columns, 1000 columns. But the calculation which I'm going to, you can say, which I'm preferring, okay, that particular calculation is requiring say 50 columns only, 50 columns. So over here, if we have specified a data frame, then this particular property, once we are going to enable this particular property, it is automatically, you can say, applying predicate push down. It is going to apply certain filter mechanism by itself, and it is going to remove the unwanted data, so that you can say necessary movement will not be there. It is going to restrict the movement of unwanted data which is not in use, basically. Unwanted, however, like we are dealing with data frame, or certain CSV file or JSON file, whatever. But it is not like say the entire data within that particular file will be utilized. So there might be certain portion which is not in use. So what this particular property AQ is going to do, it is going to predicate push down, it is going to apply a certain filtration mechanism and restrict the unwanted movement of the record which is not utilized, which is not, you can say, which is not having any use. So that particular property is automatically being applied by AQE. Once we are going to enable, predicate push down will work over there. So that is nothing but movement restrict, say, the movement of unwanted record. Restrict the movement of unwanted records. So that is, you can say, a better thing which is given by AQE. Another aspects are say shuffle file consolidation. Consolidation. So like what is happening inside the Spark? Say once we are going to apply a filter, or you can say column pruning, or you can say removal of rows. Okay, so at that moment, what we will have, say, the data size, or you can say the data size is being on you, will be decreased, and we will be having small size of file. So Spark is not, you can say, working in a good way once we are having the files with, you can say, small size. Say we are having uh, say the files in KBs, then Spark will not give the good performance, because like it is going to, you can say, uh, all the, you can say, big data world solutions are not, you can say, good to work with small files. So we need to have big files, or once we are having say the files in heavy size, then we will be able to get the performance, a good performance, basically. So addressing and the monitoring related stuff will be very less at that moment. That's why. So this particular, you can say, property, what it will do, it will automatically do the consolidation of those small files into the bigger one, and like small files will be combined together, and we will be having the bigger file. So that is another, you can say, benefit of AQE. And with the help of that, like shuffle file consolidation, like once we are shuffling the records, once the shuffling is there, then movement of records will be, uh, those particular, you can say, file will be clubbed together, and the Spark is able to, you can say, optimize the performance. So these are the things which are possible just by setting one property. But based upon, you can say, change of one property only, that is AQE, we will be able to uh, get the betterment for skewness handling. We will be able to uh, do predicate push down. We will be able to do shuffle file reconsolidation. So these particular things are possible just by setting this particular property on spark.sql dot adaptive dot query adaptive dot enabled enabled adaptive dot enabled and we can just set it to true. Okay, so at this moment, like config, at this moment the AQE will be enabled, and we will be able to overcome by these particular situation. Predicate push down, it will work, and adaptive skewness handling, it will also work. Shuffle file consolidation, it will also work just by setting this particular property. And over here, just try to mention say .config and say this is the property, like adaptive spark.sql.adaptive.enable and true. And how we can give memory, spark config and spark dot executor dot memory and say 16G. Okay, so this is the way, like in order to set the memory and in order to set the adaptive query enabled. Adaptive query enabled. Now, this is the way in order to set the properties. Adaptive query enabled, and over here we have mentioned the executor memory, and this is the stuff like the properties which we have given in our previous session, like executor core and executor memory is given. Okay, executor memory and executor instance and executor memory. Okay, so just have a look and ask if you are having any doubt. Then we will have certain I will have certain questions. Do you have any question? Okay, so say we are having certain data. I'm asking something. Just have a look onto the data. Let me pick from. Okay, so say we are having this particular data. This is the data that we are having. Let me share it with you all. Okay, so this is the data, and what I want I want to have a Spark SQL query from your side. You just need to tell me uh, the name, the schema what we have given. Okay, I want to have the name of persons from this particular data set which are having age greater than 30 and greater than 30 and department equal to say R&D. Yeah? Not what I want. Query from your side, name of person where age is say greater than say 29, 29 and department equal to say R&D. Yeah? I want a query from your side onto this particular data. Name of person where age is greater than 29 and department equal to R&D. Write a Spark SQL query for me in order to calculate this particular stuff. Is the problem statement clear? Shivam, Naresh, Swati, Rahul, Vandana, Rohit. Is the problem statement clear?
Okay. Can you please show the question? Okay.
And do this with data frame as well. with Spark SQL and Spark data frame, PySpark data frame. Okay. Shivam, Naresh, Swate, Rahul, Vandana, Rohit. Anyone has done the same? So Rahul, let me check the code from Rahul. Okay, so will you be able to create a data frame based upon this particular list? Huh? Rahul, hmm? Query is fine. Huh? There is not an issue. You need to use inverted commas as well. Huh? Okay. So query is fine. Huh? But will you be able to create data frame?
Like first we need to read this.
This is already there as a list. Huh?
Mhm.
This is the way. Huh? You need to give the schema as well. We don't have name, right?
Yes, yes, yes.
Okay, so you need to give the schema as well. Huh?
Schema as well, and then we will create the data frame.
Data, and then you need to pass this particular schema. Data is
Okay.
this particular list. Huh? Right?
Okay, data is this
So,
and this is the column. Okay.
okay, so you are having student data, and then like Spark SQL select name from data 1 where is greater than 29 and department equal to R&D, that is fine. It will work. There will not be an issue. What about with data frame? PySpark data frame. So let me create a notebook. New, say week 13, day 20. Okay. So we are going to copy boilerplate code. So Spark session has been created. Now we are having this data. Hmm. So what is the issue? Engineering. Hmm. Student data dot show. So this is the student data, a data frame which we have created based upon this data one. Data one as a list, and based upon this we have created a data frame student data, and we are going to list the record of this particular data frame student data. So the execution has been started, and execution has been started. Rohit, Vandana, Swate, Shivam, why are you not trying? So we are having this particular data frame. Okay, and now what we can have this particular query which is pasted by Rahul. So spark.sql, and we just need to create a temp view, basically student data dot create or replace temp view, and we can give a name data one, say data one. So let me give a good name, say student record, student table. Okay, so this is the table, and this is the temporary view what we have created onto top of this particular data frame, onto top of this particular list. First we have created a data frame. Onto top of that particular data frame we have created a temp view. Now on that particular temp view I'm going to run a particular query, like select name from the student table where is say greater than 29, and department, and the department is say R&D, yeah. Okay, and name df, say output df, let me output data frame, data frame, and output data frame dot show. Okay, so this is the stuff that I'm having. The execution has been started. Spark.sql select name from student table where A is greater than 29 and department equal to R&D. So this is, so based upon this, like what we are able to get, Rahul. So Rahul, Rahul has shared the execution, shared this particular query, and Rahul is, you can say, the outcome with respect to this particular query. So how we
Mhm.
can do it with Spark data frame? Naresh, Swati, Vandana, Rohit, Shivam, how we can do it with data frames? With filter condition, can anybody tell me how we can do this?
With the help of filter condition.
Hmm?
With the help of filtering.
Speak loudly.
With the help of filtration. First, we need
Mm-hmm.
to create a data frame. Then we will have to
Filter,
create value, and then
df.filter.
we will apply.
Mm-hmm. Okay. So student data dot filter, and we can have the filter based upon the age column, and is say greater than 29, and so filter call is and and call department. Department, which department we want, equal to R&D. R&D. Call. And let me copy and paste it over here. So we need to import call. From PySpark dot SQL dot function import call. So student data dot filter column is greater than 29 and column department equal to R&D, and we are moving it to result data frame. Call has been imported, that is fine. Okay, and result data frame dot show. So the execution has been started. Okay, this is the initial data frame what we are having. This is based upon Spark SQL and this is based upon, say, the execution of based upon the data frame. So this is based upon data frame and this is based upon Spark SQL. And what we are able to get, like we are able to get the same stuff like Rahul is there. If you want, like you can drop the remaining columns as well, but that is fine. Like with respect to this particular like Spark data frame as well, we are able to get the outcome. We are able to do the filtration and all. Now, what you need to do on to top of this particular data frame, say, you just need to like write it onto the disk by utilizing uh, the standard write API and store it in save it in Parquet format. Save it in Parquet format. What can be the code in order to write it in PySpark format? You just need to share that particular code. We are like moving step by step. First of all, like we were having a particular data frame, we were having a particular list, and onto that particular list we have created a data frame, and data frame was not having the schema, so we have given a schema, and then we have created a temp view on to top of that particular data frame. From that particular you can say view, we have done the execution with respect to our requirement. Now whatever the data, like whatever the query what we have executed, same thing we have done with respect to the PySpark data frame. Now what I want, we just need to write it in Parquet format. I just want to have the outcome in Parquet format. And just remove this particular query. Okay, remove this particular stuff, like we are going to have is greater than 29, and I just want to write, I just want you to write a code to store the result data frame on disk in Parquet format. Df dot filter is greater than 29 and department. Will it work, Rohit? Will it work?
And I not run on this code, but it just simple. When you ask that time, so just I given that command.
Mm-hmm. It will throw certain error.
because the
Yeah,
column is not
maybe
defined.
that age and don't need to put the column name and all the things. It was just when
Yes,
you
yes.
ask, it is given
We are
inside.
not explicitly identified which one is the column.
Yeah, column need to be added.
That will not work. So now you need to tell me the code to write it in Parquet format on disk. So this is the result that we are having, and I want to write it in Parquet format and do the partitioning based upon department as well, utilize the partition by clause as well, and do the partitioning based upon department. Try to share the code. I'm going to share 50 questions with you all. Okay, I have prepared an assignment and that will give you more insight about uh, PySpark, and try to like now what we are going to do, like if say Rohit has completed the assignment, then say we are going to have certain groups, so say Rohit and like Shivam are in one group, so Rohit assignments will be checked by Shivam and Shivam assignment will be checked by say Rohit, so you will be able to see different flavors, probably like what is there in Rohit mind, it may not be possible like Shivam is moving with the same approach, so approach might change, and it may change person to person, so at that moment like we will be having different flavors, and we will discuss with respect to those particular assignments. Basically like we have gone through with uh, a lot of stuff from the Spark side, but until unless we are not going to leverage those particular things, then things will not be clear, so that particular assignment will give you an insight, and you will have a good confidence. If you are going to complete that assignment, definitely you will have certain confidence, and you will be able to face the interviews as well, post going through with that particular assignment, you will be able to handle the assignment you can say interview with respect to coding interview related stuff, you will be able to handle, so that will give you uh, give a boost in your confidence, and by exchanging you can say assignments, you will be having the idea of different strategies, like in order to work on on a code, how the second person is thinking, so that particular approach will give you will give certain benefit. So I'm going to share that particular assignment by EOD, and you just try to work on that assignment and try to complete on priority basis, so what will be the code for writing the data on disk? These are the standard you can say questions which are being asked during the interview, like tell me how you are going to create a new column, tell me how you are going to store the outcome in Parquet format, how the partition by clause is working inside the PySpark, so these are the standard interview questions which can be asked. Sometime it is like the interviewer will ask, tell me the 40 configuration 10 or 20 configuration parameters that you have set, okay, like executor memory, executor core, executor instance, okay, so these are nothing but configurations, AQE, partition by, bucket by, so those particular things are nothing but parameters, so in that particular way you need to answer. So what will be the the standard write API in order to write this particular data frame on disk? What will be standard write API? So that is result data frame. Result data frame. Let me write it for you. Dot write and dot write at what we can have dot say mode. Let me utilize say overwrite mode. Overwrite. How many modes are there? How many write modes are there in PySpark? Swati, how many write modes are there?
Suppose
Mm-hmm. Overwrite. What about the remaining three modes? What are the names?
name is override, error,
Mm-hmm.
then fail fast,
Fail first is write mode or read mode?
read mode, sorry,
Hmm.
and the third one, 1 minute. Mm,
Hmm.
override, append, ignore, and error.
Overwrite, append,
Ignore
ignore,
and
and
error.
error. What will happen in ignore and an error?
Ignore operation will be basically ignore the operation if the file already exists, and error will give you an
If
error
file
if the
already
file is
exists or
existing.
if file already exists or path already exists.
Path. File path is already existing, then it will give you an ignore error. It will not write the file over there, and then in error, if the default path is already there, then it will throw you the error that that path is already existing.
Hmm. Okay, that is fine. So we were talking about the standard write API, yeah. So mod override, option header true, format parquet, partition by department. Then what I can have, let me use say, compression as well. Option dot compression, say compression and the compression. Let me use say LZ4. Compression is fine. Now dot say path, dot option path and for this particular path, let me try to have a path. And let me use this particular path. Price data, price spark. Hmm. Test. So this is the path and say dot save. Hmm. So this will be the standard write API, which is going to, you can say, partition this particular outcome into four partitions, and it will be partitioned by department. It is going to store the outcome in Parquet format, and mode is override. Option, option. The path is this one and save, and spark dot stop. Spark dot stop. So this is the way in order to write the result data frame onto a specified location. So let me open this particular. So over here the test folder will be created. Inside the test folder we will be having the the departments. So execution has been started, and soon we will be able to get the outcome. So this is with respect to Spark SQL, uh, PySpark data frame. Now the writing is going on, and it has written the outcome, and we are having test folder. We are having departments: engineering, R&D, RF, and telecom. So with respect to each and every you can say data or partition, we are having the outcome. So that is the way in order to like do the execution based upon a particular list. We have created a data frame by giving the schema, and onto that particular data frame we have created a temp view, and then you can say executed a particular query, SQL query, try to do the execution based upon the Spark data, PySpark data frame, and finally we have written the outcome onto the disk. So that is like the simple, you can say, program. Now what you need to tell me in order to like what we have gone through with the different topics, like if you want to have the adaptive query execution, so you can set that property over here while creating the Spark session. Now you can have like executors, drivers, and we will be having driver memory, driver core, uh, like cores for the driver as well. We will be going to discuss about these particular properties once we are having the AWS EMR cluster. Over there you will be having the information like this much of cluster, we these are the nodes in our cluster, and this is the master, and these are the remaining worker nodes. Onto the worker nodes, how we are going to divide the how we are going to create the different executor. This is one node cluster only, so local machine is not giving us a correct picture, but once we will be running these particular things onto the EMR cluster or on Databricks as well. So we will be going through with Databricks as well on with respect to these particular things, and we will be changing these particular properties over Databricks as well. So those particular things will give you more insight, but first, like, we need to have the basic understanding how to like read the data, how to do the processing with Spark SQL, and how to, you can say, do the processing with PySpark data frame. And then finally, once we are having the outcome, how to write data. So in entire PySpark program there are three phases only: reading data, processing data, and finally writing the outcome. So reading and writing, that is more or less fixed. We just need to change the file type or location. Rest each and everything will be the same only. In the middle portion we need to play, and over inside the middle portion we guys are going to utilize a lot of things, like partitioning, bucketing, broadcasting, changing the different date formats and all, applying queries, okay, in order to create new columns, dropping certain columns, removing certain rows, applying filtration and all. So a lot of thing is done inside the middle portion, that is the processing of the data. Okay, so that we need to think before moving on to the EMR and Databricks. So tomorrow, what I will give you the insight about how to create a Databricks account. Second, like I will be going to, you can say, give you certain insight like how to create an EMR cluster. So those particular things we are going to discuss in tomorrow's session. And third, like how to deal with date and time data, how to deal with the data which is having, say, different date formats. It might be possible we are getting the data from different data sources, and somewhere we are having DDMM format, somewhere I'm having YYDDMM format. But for the processing perspective, we just need to uh, convert the entire data in uniform format, so that processing will be done. Tomorrow we will discuss how to deal with different types of data, different date and time format, okay, and convert it into the universal format for the processing perspective. So that particular thing we are going to discuss. Second, like how to create the EMR and Databricks cluster for the execution. So far we have done the execution onto the local machine. Now we will try to have the look and feel of the cloud environment, that is Databricks and AWS. Databricks we are going to have onto the Azure cloud, and EMR we will be having onto the AWS. So I will give you insight, I will give you the understanding how to create those particular cluster, and that will be beneficial for you in order to face the interviews. So that's it for the today's session. Let me stop recording.